Today I'm going to talk about inverse trig graphs. The inverse trig graphs are y equals inverse cosine, inverse sine, inverse tangent. You can write it like this with the little inverse function symbol, or you can call it arc sine of x, arc cosine of x, arc tangent of x. And this should be a review of what you learned last year in Algebra 2. First of all, if I take a look at just a regular y equals sine of x graph, notice the domain is all real numbers and the range goes from -1 to 1. Well, in any inverse function, you remember that the x and y are switched, and the only kind of functions that can even have an inverse are one-to-one functions. One-to-one functions must pass the horizontal line test, so any sine or cosine curve is not a one-to-one function, so it really couldn't even have an inverse. But what is done is the domain is restricted. So if you restrict the domain to force this into being a one-to-one function, what you would do is you would cut off this part of the graph and this part of the graph. So the only part of the sine function that remains is from negative x equals negative pi over 2 to pi over 2. And if you restrict the domain that way, then you have a one-to-one function. So down here we can say we can restrict domain to negative pi over 2 to pi over 2 to force a one-to-one function. Therefore, we can create an inverse. An inverse function is simply just switching all of the x and y coordinates. So this coordinate right here is pi over 2 comma 1. This one is 0, 0. And this point down here is negative pi over 2, 1. The domain of this is from negative pi over 2 to pi over 2, which means the range of the inverse will be negative pi over 2 to positive pi over 2. The range of this is -1 to 1, which means the domain of the inverse is going to go from -1 to 1. And like I said, all we do is switch the x and y values around. Oop, this is -1. So instead of negative pi over 2, -1, we're going to go to -1, negative pi over 2 and plot this point. 0, 0 stays 0, 0. And pi over 2, 1 becomes 1 pi over 2. We're not going to connect these in a straight line. We're actually going to reflect this across the line y equals x. Y equals x would kind of go along this way. So this function flips over this line y equals x, so it kind of comes up like this. It's a concave up graph over here, and this part down here is a concave down graph. And that's pretty much all you have to know for y equals arc sine of x. Make sure you know the domain is from -1 to 1, and the range is what the domain was in the regular sine function, which is negative pi over 2 to pi over 2. The next thing we're going to look at is a cosine graph. This is y equals cosine of x. And I only graphed from 0 to pi because if I continued all the way up to 2 pi, this would create a function that was not one-to-one. And I want to force this into being a one-to-one function, which means I have to restrict the domain to 0 to pi. And the range is still -1 to 1. So I'm going to take this graph and all of the points. This point is 0, 1. This point here is pi over 2, 0. I'm sorry. No, I was right. Pi over 2, 0. And this point over here is pi -1. So I'm going to take those 3 points and create an inverse cosine graph. Well, since the domain goes from 0 to pi, I know my range is going to go from 0 to pi, so my range is never going to be negative. So I'm just going to make my x-axis right down here on the bottom, and this will go up to pi. On my x-axis, I'm going to go from -1 to +1. So the point 0, 1 becomes the point 1, 0. This point pi over 2, 0 becomes 0 pi over 2, so it has a y-intercept. And then this point pi -1 becomes -1 pi. So we'll put that point here. And to reflect this across the line, y equals x, we're going to start out with a concave down portion of the graph and end up with a concave up portion of the graph. So this is y is equal to the arc cosine of x. And the domain and range are just switched here. The domain, -1 to 1, range 0 to pi. And then the last thing I'm going to show you, the last inverse trig function that we have to know how to graph, is the arctangent graph. So the tangent graph has vertical asymptotes of x equals pi over 2, x equals -pi over 2. Goes to the origin. It comes to the point pi over 4, 1, and -pi over 4, -1. So here is just a regular old tangent graph. And if we restrict the domain, so it can be a one-to-one function, the domain is not including, so I'm going to have rounded brackets, rounded parentheses instead of square brackets. The domain is -pi over 2 to pi over 2. And the range is all real numbers because it goes forever down and forever up, from infinity, from -infinity to infinity, if you want to write it that way. Now, if I wanted to graph the arctangent function, instead of vertical asymptotes, I'm going to have horizontal asymptote. So this horizontal asymptote is y is equal to pi over 2. And this horizontal asymptote is y is equal to -pi over 2. And we have a point here called pi over 4 and -pi over 4. And we have a point here, 1 and -1. So this point right here, pi over 4, 1 becomes 1 pi over 4. 0, 0 stays 0, 0. And -pi over 4, -1 becomes -1, pi over 4, which is down here. And this is a concave down graph, which continues to approach the vertical asymptote. And then this part down here is a concave up graph, which approaches the horizontal asymptote, 2 of them. And this one you might want to put as the vertical asymptote. It's got 2 vertical asymptotes, y equals tangent of x. And this graph right here is y is equal to the arc tangent of x. And this has a domain of all real numbers, my fancy r, or if you want to write -infinity to infinity. And it has a range of not including -pi over 2 to +pi over 2. And that's it for the inverse trig function graphs.